Okay, so here is the problem that I was talking to you about before. This comes from a different textbook. Let me walk through this problem using a little bit of the book here and then run the code for you. And that should give you a pretty good idea of what's going on here in the code to see if this is the kind of thing that you think would be helpful for your project. That sound good? So I'm going to go ahead and start up here. Let's see right here, personal scheduling. One of the most common applications of this type of analysis involves personal scheduling for a company. The objective is to schedule the work times of company's employees to minimize the cost of providing the level of service specified by management. So they're trying to balance this cost of having too many people here to tend to customers' needs, right? That increases costs if you have too many employees. So they're trying to match employees with what they think the benefit is going to be. And in this particular situation, this is an airlines company. They're adding more flights to and from its hub airport, so they need to hire additional customer service agents. But it's not clear just how many more should be hired. In this case, management recognizes the need for cost control, but also wants to provide a level of service that's satisfactory to customers. So there's a trade-off between these two factors, the satisfaction level and cost. So we're trying to figure out, and this company's trying to figure out how many agents to have at certain time periods. So it says based on the new scheduled flights, analysis has been made of the minimum number of customer service agents that need to be on duty at different times of the day to provide a satisfactory level of service. There's some other things here in the queuing level in a different chapter that determine the minimum number of agents needed. In fact, that might be another interesting perspective on your project here. Sounds like you get that number from corporate, so you may not have enough data to really make any kind of other estimate than that. So this says these numbers are shown in the last column of table 3.5 for the time periods given in the first column. The other entries in the table reflect one of the provisions in the company's current contract schedule with the union. This says that each agent works an 8-hour shift. So they have these 5 different shifts of 8 hours each. That's in the union contract. Now you probably don't have unions where you're at, but this is how to set up this model. So what it's going to do is we're going to put into the model a minimum number needed, right? So if we go ahead and type in the minimum number of agents needed into this column, I'm just going to copy straight from the book: 49, 79, 65, 87, 64, 73, 82, 43, 52, 15. These are the minimum number of agents needed for these particular time periods, right? So now that this program is going to help us figure out how to allocate workers across these shifts and in these time periods. Okay, so let's keep reading here. Um, check marks in the main body of table 3.5 show the time periods covered by the respective shifts. Because some shifts are less desirable than others, the wages specified in the contract differ by shift. For each shift, the daily compensation is shown in the bottom row. The problem is to determine how many agents should be assigned to the respective shifts each day to minimize the total personnel cost for agents based on this bottom row, while meeting or surpassing the service requirements given in the last column. Okay, so we're going to take this daily cost per agent and we're going to put it in our spreadsheet up here. 180, 160, 175, 180, 195. So now that we have cost in the model, we're trying to minimize the cost, but we need these minimums number of agents in these time periods. So I won't go through all the details here of this problem. It might be helpful to read that if you're interested. But let's focus on the model here. And what I'm going to do now is I'm going to run the model. So we have the inputs to the model set up. Now I'm going to go ahead and run it. And it looks like it's already been run because we have these outputs here, but I'm going to go ahead and use Solver to run this. Yep, it's already been set up and run. Let's see, what does it say? Let's see, what am I missing? Minimize total cost, change the number working, total number working equals an integer, total working is greater than or equal to minimum need. Okay, so I had forgotten to put in the zeros and ones here. So I've put those in. These ones and zeros just correlate to the particular shift, right? So for 6 a.m. to 2 p.m., we're going to do a 1 here from 6 a.m. to 2 p.m. From the 8 a.m. to 4 p.m. shift, we're going to put a 1 in this table for 8 a.m. to 4 p.m. From noon to 8 p.m. is here, and from 4 p.m. to midnight is here, and then 10 p.m. to 6 p.m., 6 a.m. is here. Now that we have those inputs, we can run the model. And this will give us the number of people, number of employees that we need to work here in each of these shifts to maintain the minimum number needed. Notice that some of these are larger than the minimum, but none of these are lower than the minimum, right, for each of these time periods. And it minimizes the cost. So we know this is the lowest cost to achieve these minimums given these shifts and these time periods. Now, this isn't exactly your particular situation, but maybe you can tweak this model to produce this down here. Now, how would you make this into a project? You could create some input boxes that identify these costs. You could create some input boxes to identify these minimum needs, right? It doesn't need to be this many, right? Maybe you have different time periods here. But maybe there's a way to alter this to help this from a scheduling perspective, which is to minimize cost, but based off of a minimum amount of workers needed for a particular time frame. Hopefully that helps. I'll go ahead and send this sheet with these numbers to you in an email, and let me know if this helps. Thanks. Bye-bye.